For those of you who've had a bit of exposure to calculus, let's take a moment to talk about why Newton's method works. The general form states that xi plus 1 is equal to x minus f of x over f prime of x, where f prime is the derivative of the function. So in the case of square root of 10, what we're really doing is finding this root to the polynomial x squared minus 10. So we started with a value of x equals 1. That puts us about here. Remember, the derivative is the slope of the function, derivative being f prime, which if we extend the slope of the function outward, we'll intersect the x-axis approximately here, 5.5. Going up and evaluating the function puts us off the charts, but following that derivative put us back down to about 3.659. Again, going up, hit the function here. The derivative brings us closer to the final value of x we're looking for. In this case, 3.196. Going up and down, up and down, up and down, we get closer and closer and closer till we converge on the value we are looking for. Now for square roots, let's say our function f of x is equal to x squared minus a. In our case, a is equal to 10, because that's the number we're finding the square root for. Using the power rule, the derivative f of x is equal to simply 2x. Plugging that into this formula, we get xi plus 1 is equal to xi minus x squared minus a divided by 2x. I can put the subscript so I'm consistent. By doing a bit of simplification, we find xi plus 1 is equal to xi over 2 plus a over 2 divided by xi. So for example, if you wanted to find the square root of 5, that would be xi plus 1 is equal to xi over 2 plus 5 over 2 is simply 2.5 divided by xi. You can make a table and run through the same process to find the value for the square root of 5. You may be asking, oh, wait a minute, this applies to square roots. What about cubed roots, fourth roots, fifth roots, or any root for that matter? Why yes, there is an extension, as you will see here. Square roots we've already seen, 1/2 x plus a over 2 divided by x. For the cubed root, 2/3 x plus a over 3 over x squared. Fourth root of a, 3/4 x plus a over 4 divided by x cubed. Are you starting to see the pattern? If you plug in the most general form to our original equation, you should get something like this. I leave the exercise to you as a viewer to verify this pattern. And I encourage you to run through some exercises on your own, verifying that the roots, according to these equations, match those when you punch into your calculator. Let me know your thoughts in the comments below. Thanks for watching. I'll see you next time.